Hi, this is Victor Morganti from FactEngine. Today we'll be looking at some extraordinary technology available exclusively to FactEngine customers, generating database queries from natural language using large language models and transformer models trained on a domain-specific model. We've got Boston open in front of us, and we'll look at FactEngine inside Boston, but we are making an API available, a web-based API available to our clients. So from inside Boston, we've got a model open in the Model Explorer, and it's a model for cinema bookings and some attribution. The original cinema bookings model from which this is derived was developed by Data Constellation and made available on GitHub. The cinema bookings model is for cinemas where people can make bookings for seats for sessions to watch film at that cinema, and where seats are in sections in that cinema and where a seat is in a row in that cinema. We know in Boston we can view the model as a property graph schema or a entity relationship diagram. So this is the same model viewed as an entity relationship diagram or as an object role model. Object role modeling provides the foundation for the technology you're about to see. So given our object role model, we have the predicates that are available for our edges in our property graph schema. So for instance, a booking is for a session, and a session is at a cinema. A booking has a seat, and a seat has a booking. A seat is in a row, and a row is at a cinema, for example. Those same predicates are available in our entity relationship view, where we can see that a seat is in a section and a seat is in a row, and a row contains a seat and a section has a seat, for instance. So our object role model provides the predicates for our property graph schema and our entity relationship diagram. These predicates allow us to do natural language queries in FactEngine. What I'll show you now is natural language queries converted to FactEngine's controlled natural language, converted to a database query language and executed against the database. So in natural language, we might ask, what movies are showing at the Great Western Cinema today? That natural language query is being farmed out to a large language model and converted into controlled natural language, reading which film is showing at Cinema Great Western Cinema on date time, converted to a date matching today's date. And we can see in the results down here that Greece is showing at the Great Western Cinema today. Here's the SQL query that returned that result, and we know in FactEngine that FactEngine can produce SQL or Cypher for Neo4j or an open Cypher database, or TypeQL for a TypeDB database. This particular database is an SQL-based database. So we know that Greece is showing at the Great Western Cinema today. So we might ask, what time is Greece showing at the Great Western Cinema today? So we want to get more specific information. And now the controlled natural language query has come back. Which session is showing the film Grease at the cinema, Great Western Cinema, on today's date, and we're returning the date time. So today is the 19th of January 2023, and Grease is showing at 12 PM. Here's the SQL query, and for those who study natural language to SQL or natural language to Cypher or TypeQL, we know that going straight from natural language to SQL or Cypher or TypeQL to a database query language is fraught with problems. The secret sauce of FactEngine is the ability to convert a natural language query relatively easily into a controlled natural language query, which is then deterministically converted into a database query to get our results. So what time is Grease showing at the Great Western Cinema today is converted to which session is showing the film Grease at the cinema, Great Western Cinema on today's date, and returning the date time. Now the ability to do this is by training or domain specific training over the generative transformer that converts the natural language to a controlled natural language. And the resulting percentage of successful queries is very high compared to, say, if you wanted to go directly from natural language to SQL or Cypher or TypeQL. So we know that Grease is showing it at 12 PM, and we might ask now what seats are available at the Great Western Cinema to watch Grease today at 12 PM. Let's see how it goes translating that. So we're saying which seat is in the Great Western Cinema and has no booking for a session to watch the film Grease at the Great Western Cinema on today's date and at the time 12 PM. So we've successfully converted quite a complex query into quite a complex controlled natural language query to get our results. So these are the seats that are available, and here is our SQL, which is quite a complex SQL for our particular model. So great, we've found some seats that are available, but we want a seat that's in the deluxe section. So if we look back at our model, seats are in sections, and we want to feel a bit special, so we want to sit in the deluxe section. So I might ask, which seat in the deluxe section at the Great Western Cinema is available to watch Grease at, well, let's try this, today at 12 PM. So we want a seat in the deluxe section. So it's going to convert that to FactEngine query language, which is controlled natural language. And we've got a seat, it's 20A at the Great Western Cinema. And the controlled natural language is which seat is in the section deluxe and is at the cinema, Great Western Cinema, and has no booking for a session to watch the film Grease at the Great Western Cinema on today's date at 12 PM. And here's the SQL query behind that. So we think this is extraordinary technology. It's available to our customers now, and it's unique to FactEngine, and we're really excited about bringing this technology to the world. Thank you very much for watching. Please get in touch if you're interested in the API or using Boston and FactEngine to query your database using controlled natural language and natural language. If you like the video, please hit like and subscribe, and I'll talk to you in the next video. See you.